So yes, in the previous class we start with the flip flop. So why flip flop is used? Okay, why flip flop is used?
Store a bit.
Flip flop is used to store a single bit.
To store, yes, yes.
Okay, to store a single bit. There are four types of different flip flops are available: SR, JK, T, and D. Okay, SR is basically set reset. JK by the Johnson. Okay. T is the toggle, and D is the delay flip flop. Okay, most probably we use the D flip flop. Okay, most probably we use the D flip flop. It is a basically buffer, and it will be used to store a bit for a duration. Okay. Now, how much duration? That is all dependent on the applied input signal. The input signal that we applied, on the basis of that one, it will be defined that at what time it will be stored the information. Okay. So all the, particularly if you see the memory element. Okay, these are the only the combination of these flip flop. With the help of flip flop, we can design a resistors. Okay, and that resistor will be used to store multiple bits. Multiple bits. Like for example, if I want to store a 8 bit. Okay, so what we do, we have to create a register. We have to create a register that will be used for 8 bit storage. Now this register have a 8 flip flop: FF1, FF2, FF3, up to the FF8. Okay, FF1 to FF8. So that particularly register will store a 8 bit data. Okay.
Yes, sir.
No. Now, the particularly this type of circuits is under the category of sequential circuit. Sequential circuit. Okay. Till now, the particularly part or basically the component that we study in the digital electronics is the combinational circuit. Okay, so this is the difference between the combination and sequential. It is a combinational circuit. Either we are talking about the gates, or we are talking a DMUX, MUX, encoder, decoder, adder, or subtractor, either the half adder or full adder. Similarly, half subtractor, full subtractor. Okay, so these particularly are the combinational circuit. Now, with the help of this one, with the starting of this flip flop, we switch into the sequential part. Okay, the basic difference between the combinational and sequential circuit is that in the case of combinational, any operation can perform at any time. Okay, that means there is no synchronization is required. Okay, there is no synchronization is required, or we can say the synchronization is not required. Okay, so this particularly is called the sequential, the combinational circuit. Now, in the case of sequential circuit, there is synchronization is compulsory. Okay, synchronization is compulsory. That particularly synchronization, basically the synchronization signal, or we can say the mm, reference signal, will control performing operation. That means which operation I have to perform at what time, that will be defined by the one synchronization signal or the reference signal. And this synchronization signal or reference signal, we call them as a clock signal. Okay, clock signal. That clock signal is nothing but a rectangular pulse. Okay, that particularly rectangular pulse. And that pulse will decide the operation time. Okay, so if you are talking about the rectangle pulse, so this is my rectangle pulse. Okay, this is my rectangular pulse. Now in the rectangular pulse, the first thing is the duty cycle. Duty cycle. Duty cycle is what? It is basically the time period of on the signal upon time period of on plus off the signal for a single pulse. For a single pulse. Yes. Yes, Nikhil.
No, sir.
Okay. So basically, the duty cycle is T on and T off, T on upon T on plus T off. So, like for example, if we say that one pulse will be lies from 0 to 2 seconds, okay, the on time period for this one where the clock magnitude is high, and off time period is where the clock magnitude is 0. Okay, so if I say this is the 1 second, so what is the duty cycle? T on time period is from 0 to 1, that is a 1 second. Upon T on plus T off is the total time duration, that is 2 seconds. So 1 by 2, that is the 50% is the duty cycle. Okay. Now there are four different things. Is that one is the positive edge. This one is the positive edge. So I just define as a PE, positive edge, where the magnitude of the clock signal lies from 0 to basically change from 0 to 1. Okay. Second is negative edge, where it will be switched from 1 to 0. That means any negative edge. Okay. Third is positive level, duration at which the magnitude will maintain as a 1. Okay, duration at which the magnitude will be maintained as a 1. So basically, if I represent this one, so it is this one. Okay, it is this one. Okay, so it is a positive level, and fourth one is negative level, where the magnitude will maintain as a 0. This one, negative. Okay, any doubt?
No, sir.
Okay. Now, if we are talking about the positive level and negative level, so generally this positive and negative level will not use for the synchronization. Positive level and negative level that will never use for the synchronization. Why? Because positive level is not a single duration. Okay, positive level is not a single duration. It will be lies from this region to this region. From 0 to 1 second, the level is positive. Similarly, for the negative level, it is 1 to 2. 1 second to 2 seconds, it is a negative level. Okay. So initially, designing of or basically implementation of any flip-flop will be dependent on one basic component, that is the latch. That is
Yes, sir.
latch. So basically the difference between the latch and flip-flop is latch is basically a lever trigger device, where the flip-flop is the
Yes,
edge
trigger.
trigger device. Okay. So now second thing is that the flip-flop second thing is that when we basically explain the flip-flop part, so there are three types of tables we design. Like for example, we already know about the truth table. Okay, So there are three types of table that will be designed for a flip-flop part. One is the truth table. Second is the excitation table. Okay, and truth, excitation, and one is the response table. I think. Wait a minute. Flip-flop. For the flip-flop, one is the truth table. Second is the excitation table, and third one is the operational table. Operation table. Yes, anyone is speaking anything? Okay, or we can say the characteristics table, operation table, or the characteristics table. Okay, truth table is designed between the input and output. Input and output. Where the excitation table will be defined with the input and output with considering the previous output. Previous output. Okay, and characteristics table is basically designed with the previous output, current output, and the inputs. Previous output, current output, and the inputs. Okay, so this characteristics table is designed. Basically, we implement this characteristics table when we require a conversion from one flip flop to another. Okay, conversion from one flip flop to another. Okay,
Yes,
now
sir.
we start with the SR flip flop. Mm, latch covered in your course or not? Mm,
Yes, sir. Professor covered latch.
okay, latch part also professor covered. So we start with the SR latch. Mm, This is the S R Q bar Q. Okay, so there are two particularly circuits that are available for the latch. SR latch is one using the NOR gate, second using the NAND gate. Okay, so S R, Q, and Q bar. Okay, SR, Q, and Q bar. Okay, so there are two particularly combination of the SR and R latches available. Now, if we draw the truth table of these two, so first we design the truth table of NAND gate using NAND gate. So S R Q n plus 1. Q n plus 1 is the output of the next state. Output of the next state. Now, if S value is 0, okay, S value is 0. So when S is 0, we know that this is the NAND gate. This is the NAND gate. In the NAND gate, when one particularly input is 0, output is always 1. So Q n plus 1 is 1. Okay, Q n plus 1 is 1. Now, if Q n plus 1 is 1, so this particularly 1 will be going in this way and R is 0. Okay, R is 0. So when it is a 1, it is a 0. Again, the Q bar is also 1. So Q n plus 1 bar is also 1. Okay.
Yes, sir.
Hmm.
But sir, it's a complement, no?
Yeah, it is a complement. So this particularly SR latch will be giving me Qn and Q plus 1 bar, both are same.
It's an invalid output.
So it is called the invalid output. Okay. When S is 0, R is 1. So because of S is 0, Q is 1. Okay. And when Q is 1, it is coming this one. So it is become both are 1. So Q bar is 0. Okay. Or it is a 1 0. So when S is 1, now in this case, what we consider, we can initially calculate the Q bar. So when R is 0, so Q bar is 1. Okay. When this is 1, S is 1, this particularly Q bar is also 1, so it becomes 0. Okay. And last is the when it is a 1 1. When it is a 1. So when S is 1, okay, when S is 1, till now we are not getting what is the output of the previous state. We can't identify Q bar. Okay. So let's assume that the previous state is 0, Q is 0 and Q bar is 1. Consider the previous state that before applying this one, what is the value of Q and Q bar? Okay, so what I do, I just take this particular 0 and 1. So when Q is 0 and Q bar is 1. Now this 1 will be going in this way. So 1 and 1 becomes 0. So Qn is 0. Okay, and this 0 will be coming in this way. So 0 and 1 is applied here. So R is 1 and Q is 0. So 1 and 0, it becomes a 1. So we can say this condition is called the no change condition. Similarly, the previous output that is appear across this one SR latch, we are getting the same output when we change the value of S and R as a 1 1. Okay.
Or we
Now
can
if
say it's a hold condition.
hold condition, no change condition, or buffer condition, any condition you can tell.
Yes, sir.
Now with the SR, with the NOR gate, so SR Qn plus 1, Qn plus 1 bar. When S and R both are 0. So it is 0. It is 0. Okay. Now, till the second input is unknown for us, I can't identify what is the Q and what is the Q bar. So I just consider that before this one, Q is 1 and Q bar is 0. Okay. So R is 0 and Q bar is 0. So what we are getting Q as a 1. Okay. Now this 1 will be applied here. 0, 1. So it becomes a 0. Okay. Any doubt?
No, sir.
Okay. Now it is called the no change condition because we assume that Q is 1 and Q bar is 0. Now in the next state we are getting a Q n plus 1 is 1 and Q n plus 1 is 0. So it is called the no change condition. Okay. Now when we apply a 0, 1, when R is 1, Q is 0. Okay. When this is 0, S is 0, it becomes a 1. Okay. When it is a 1, 0, when S is 1, Q bar is 0. When this one is 0 and other one is 0, it becomes a 1. And then both are 1, 1. So when S is 1, Qn is 1. Sorry, R is 1, Qn is 1. And when S is 1, again the Qn bar is 1. So it is called the invalid. It is called the invalid conditions. Okay. Now if you see the truth table using the NAND and NOR gate, you can see this particularly. Hmm? Yes, you can see. Hello. You can see any relation between these two?
It's like
Just
opposite
complement.
to.
Just complement.
Yes, sir. Yes, sir.
Okay. For the SR value in the NAND gate, using the NOR gate, we are getting the SR value 1, 1 in the NAND gate. Okay, so it is just reverse to this one. So these two are complementary. Okay. So if we change the gate, or flip flop output will be changed. Okay. To avoid this condition, we next go to the flip flop part, SR flip flop part. Okay. So in the case of SR flip flop, what we do? This particularly SR flip flop will be designed with the help of either the NAND gate or the NOR gate. For both scenario, the output should be same. For the both scenario, the output should be same. Either you implement with the NAND or with the NOR. So this is the S, NAND gate, NOR gate, R. Second, we are using the clock. It is a Q, it is a Q. Okay, or with the help of NOR gate, if I design clock. Okay. Now, if we draw the truth table of this one, so S, R, Q, and Q bar. So when S is 0, okay, and clock is applied, I say the clock is always 1. Okay, at every 1, we are taking this one. So now when S is 0, R is 0. So 0 and 1 becomes a 1 and 1. S is 0, R is 0, so it becomes a 1. Now 1 we are going in this one, so we have to check what is the previous. So if we see that my Q and I'm taking as an input, so Qn is 0. Okay, so when Qn is 0, so it will be going in this way. So it will be 0. So 1 0, Q bar is 1. Okay, when 1 will be coming, it will be go this way. So it is a 1 1 1 0. And suppose if Qn is 1, if it is a 1, so what will we are getting? It is also 1 1 1, Q bar is 0. And if Q bar is 0, so 1 0, Q and plus 1 is 1. So for both situation, we can say the Qn plus 1 is nothing but Qn. Okay,
Yes, sir.
when SR 0 1, now if it is a 0 1, so R is 1, clock is 1. So here we are getting 0. Then S is 0, clock is 1, we are getting a 1. Okay, now if it is a 0, we can say the Q and Q bar is 1. Okay, Q bar is 1. Now if Q bar is 1, so it will be going in this way, so 1 1 becomes 0. Either we apply the Qn as a 0 or Qn as a 1. Okay, because it is not dependent on the value of Qn. It is not dependent on the value of Qn. Now if we apply the SR 10, So when S is 1, clock is 1, it becomes 0. When R is 0, clock is 1, it becomes a 1. Now it is a 0, so Qn is 1 and Qn bar is 0. Okay. Now there is no particularly, it is not dependent on Qn. So either I can take a Qn as a 0 or 1. For both scenario, the output is same. Okay. Now the last is 1 1. Now when it is 1, S is 1, R is 1. Clock is always 1, so it becomes a 0, it becomes a 0. Okay, if it is a 0, so Q bar is 1 and Q is also 1. So it is also not dependent on Qn either. You can take the Qn is 0 or Qn is 1. Always it is a, both are 1 1. Okay.
Yes, sir.
Now if I combine, so this is basically called the excitation table. This is called the excitation table. Now if you are talking about the truth table, so for the case of truth table, only two input is available, S and R. With respect to this one, Qn plus N is the output available. When S and R both are 0 0, this two case. Qn plus 1 is becomes a Qn. When it is a 0 1, Qn is 0, Qn plus 1 is 0, 0 1, Qn plus 1 is 0. When it is a 1 0, Qn plus 1 is 1. And when it is a 1 1, Qn plus 1 is the invalid. Qn plus 1 is the invalid. Okay. Now here we can say it is a reset condition. Why? Because the output is 0. Okay. When we apply the R as a 1, we are getting output as a 0. That means it is a reset. Okay. When S is 1, output is 1. So it is called the set condition. So Qn plus 1 is Qn, reset, set, and the invalid. Okay. Now here we are using the NAND gate. S and R. Now in this case also you are getting the same output. So either you are using the NAND or you are NAND or you are using the NOR. S is Q bar and R is. Okay. Now if you see that with respect to S we are getting a Q bar. If with respect to the R we are getting a Q. Now if we are using this as a NOR gate, if we are using this as a NOR gate, okay, we are getting a Q in front of S and Q bar in front of R. So basically, we are taking, this is my flip flop. This is my internal circuit of the flip flop. Now, if you see any internal circuit, either it is the combination of the NAND gate or it is a combination of NOR gate. For any particularly circuit, you are getting the same. You are getting the same. Okay.
Yes, sir.
Now, if we go with the one more characteristics table, so we draw the excitation table, we draw the truth table. Now, if we draw the characteristics table, so the characteristics table is designed with the help of excitation table, where we are considering, we are just reverse the truth table by considering the Qn and Qn plus 1 as the input, okay, and S and R as the output. So when Qn and Qn plus 1 both are 0, 0. So this is the first state and this is the second state. This is the first condition, this is the second condition. Okay. Now with respect to this one, when you check the position of S and R, so S is 0, R is 0, and S is 0, R is 1. So we can say S is always 0, but R is don't care condition. Okay,
Yes, sir.
because in one situation R is 0 and in another situation R is 1. If we are
Okay.
taking the 0, 1, so this particularly the 0, 1, and this is the 0, 1. Okay. Now S is 1 and R is always again a 0 and 1. So S is 1, R is again a dot. Now 1, 0. This one 1, 0. Now it becomes a 0, 0, 1, 1, 0, 0, 0. Okay, it is a, we are getting a 0, 0. We are getting 1, 1. So 1, 0 this one. So S is 0 and R is 1. And 1 it is a 1, 1. Okay. So we are not considering these two states because it is an invalid conditions, no? So 0, 1 we are getting as a 1, 0. Okay. We are not considering these two states. Okay, and when 1, 1, so this is the 1, this is the 1. So in this particular situation, you see the R is constant, that is 0, and S is vary, it is a 0 and it is a 1. So it is a don't care condition. Mhm. Yes. So 0 1 0 cross and cross 0 cross 1. Sorry, cross 0 1 cross 1 0. Okay, so this is the characteristics table for SR. Okay.
Okay, sir.
Now the problem with the SR flip flop is there is the invalid conditions. The invalid condition. So to avoid this one invalid condition, we go to the JK flip flop. So second type of flip flop is the JK. Okay, so JK flip flop is just the extended version of SR flip flop. Uh, So if we draw the table circuit of this JK, so it is somehow similar. So JK flip flop. Okay. So this particular circuit level second is same with respect to the SR and JK. Level second is same. It is J. It is K. One clock pulse. So either I can put as a JK or either I can put as a S or R. Till now both are same. Okay, till now both are same. So the only difference that we create with the JK flip flop is that we can take a feedback path. Okay, so till now the SR and JK both are same, no changes. The only changes with that JK flip flop is in the J we can use a input of Q bar. Okay, and in the K we can use a input as a Q. Okay, so this is the only difference between the SR flip flop and JK flip flop. Yes. Any doubt?
No, sir.
Okay. So first of all, we draw the excitation table. After that, we draw the truth table and the characteristics table. So excitation table. So J, K, and Qn. So when J, K is 0 and Qn is 0. Okay. Clock we consider always 1. Either the clock is positive clock or negative clock. So at particularly which clock is available, according to this one, we consider the clock is 1. Now if clock is 1, this is 1, 0 and 0. Okay. Now Q. Okay, Q bar. Sorry, Q. So Q is 0. So this one is also 0. Okay, and this Q bar is 1. So this is 1. What is the output at this point? Yes, what is the output at this point? P1 and P2.
Both are 1 1.
Hmm?
Both are 1 1.
Both are 1. Okay. Now if it is a 1 and Q bar we are considered as a 1. So it become also 1. So what is the Qn? 0. And this one is 1 and Q we are considered as a 0. So here we are 0. So 1 0 it becomes a Q1. Now JK is 0 0. So that means the P1 and P2 is 1 1. Now what we do, we are changing the value of Qn as a 1. We are changing the value of Qn as a 1. So when Qn is 1, so here we are getting a 1. So 1 and 1, Qn bar is 0. And when Qn bar is 0, so here we are getting a 0. So 1 0 becomes a 1. Clear? Now when Jk is 0 1, so J is 0 and K is 1. Okay. Again Qn is 0 and 1. So Q is 0. So here we are getting 0. Q bar as a 1. So we are getting as a 1. So again the P1 P2 point will be 1. Okay, again the P1 P2 point will be 1. So if P1 and P2 point will be 1, so P1 is 1 and this one is 1. Now if Q is 0, Qn is 0. So this 0 becomes going to this one, so this becomes 0. So Q bar is 1. And if Q bar is 1, Qn is 0. Okay. But when Qn is 1, when Qn is 1, so this Q is 1 here. So we are getting 1 here. And here we are getting a 0. Now P2 is 0 and P1 is 1. P2 is 0 and P1 is 1. P2 is 0, that means Q bar is 1. When Q bar is 1, so this 1 is going here. So 1 1 Q is 0. Clear? Any doubt?
No, sir.
Okay. Now when J and K becomes 1, 0. Now Qn is 0 and 1. So when J is 1, so we are taking J as a 1. and Q as a 0. Okay. Now Qn is becomes 0. So here we are getting as a 0 and here we are getting a 1. Okay, so when all are 1, P1 point is 0 and P2 point is 1. Now if P1 point is 0, we can say that Q is 1, and when it will become 1, so it is coming from here, so it becomes this point is 1, 1, 1, the ending of this one is 0. Okay, and when Q is 1, so here we are getting a 0 and here we are getting a 1. So both point will be 1 now. P1, P2 point will be 1 now. So P1 is 1, P2 is 1. Now if P1 is 1, P2 is 1, check the Q. So Q is 1. Okay, so 1 and 1, Q bar it becomes 0. When this 0 will be going in this part, so it becomes a 1 0, so Q is 1. Okay, and last one is 1 1. Now Qn is 0 and Qn is 1. Okay, now Qn is 0, so this becomes 1 and this becomes 0. Okay, this is 1. So 1 1 0, it becomes a 0. Sorry, it becomes a 1. So P2 point becomes a 1, P1 point becomes a 0. Now when it is 0, so Q as a 1. Q as a 1. Now this 1 will be feedback in this particular part. So P2 is 1 and this one is 1, so Q bar is 0. Okay. And when Qn be a bit 1, Qn is 1. So Qn bar becomes 0 and Qn becomes 1. So when all 1, P2 becomes 0 and P1 becomes 1. Okay. Now if P2 becomes 0, so Q bar becomes 1. So Q bar becomes 1. And when Q bar becomes 1, so it is going to this one. So this one is 1, P1 is 1 and this point is 1. So both 1 becomes 2 is 0. Okay, so this is the excitation table. Now when we create a truth table from this one, JK Qn plus 1. So when it is 0 0, we can say the Qn that is 0, so Qn plus 1 is also 0. Qn is 1, so Qn plus 1 is 1. So we can say Qn plus 1 is equal to the Qn. When it is a 0 1, Qn plus 1 becomes 0. When it is a 1 0, Qn plus becomes 1. Okay, and when both are 1 1, okay, when both are 1 1, so we are seeing that when it is a Qn is 0, Qn plus 1 is 1. So we can say that it is a toggle mode. The previous input that we applied, previous output, it is always a toggle. So the next output will be the opposite or invert of the previous one when J and K both are 1. Okay. Now with the help of this one, we can create a characteristics table also. We can create a characteristics table. In the characteristic table, qn and qn plus 1 is the input and j and k is the output. Just 2 minutes, just 2 minutes. Now when qn and qn1 is the 0 0 and 0 0, you can see the j is 0 and k is changes. So when qn plus 1 is 0 0, j is 0 and k is the don't care because it is changing. Second condition 0 1. So when it becomes a 0 1, this particularly and 0 1, this particularly, you can see the j is 1 constant and k is variable. So j is 1 constant, k is variable. Now if we are talking about the 1 0, 1 0 and 1 0. Okay. Now you can see the j is variable, k is constant. So j is variable, k is constant. And last one 1 1. This one and this one. Now you can see k is constant 0 and j is variable, so it is a don't. So this is the truth table, characteristics table, and excitation table of JK flip-flop. Yes. Now, if you have any doubt, you can ask. Yes, Nikhil.
Sir, in the quiz 2, I have a doubt in one question.
Yes.
Comprehension type.
Comprehensive type.
Yes. Last question.
Okay. Just let me check. Mm-hmm. Mm-hmm. Yes. Just give me a second. Yes. So comprehensive.
Yes, sir.
What is your doubt in the comprehensive?
In the question 2, comprehension type, question 2.
Select the Boolean expression for C out.
Can you please show the question in the screen?
Mm-hmm. Yes. Is it comprehensive? Yes. What is your doubt?
I am not able to like approach this concept about asking in question two.
They are asking the what is the expression for the C out.
So basically, I am not able to calculate the C out or
Okay. So like for example, we are taking the P1 P naught, Q1 Q naught. With respect to that, we are getting the S1, S naught, and C out. Okay. So we are taking the four cases 0 0 0 0 to 0 0 0 1 up to the 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1. Okay, I'm taking only the seven cases. Now when P naught and Q naught both are 0 0, so S0 is 0. Okay, C1 is 0. Okay, when we add this 0 0, so if the addition is greater than 1, so we add a carry on a P1 and Q1. Okay, so P0 0 0 0, S0 is 0. Now no carry, so P1 Q1 again 0. Now P naught Q naught is a 1 and it is a 0. It is a 0, it is a 1. Now P naught and Q naught addition of these two is 1. No carry, P1 and Q1 addition is 1. Okay, 1 0. Now with respect to P naught and Q naught, 1 plus 1 addition is 0, carry is 1. Okay, carry is 1. But carry is only for the internal carry. So P naught, P1 and Q1 is 0 and 0. So addition of this one is 0 and carry is 1. So it is a 1. Okay. Similarly, here is a
okay.
1 and 1. Now in this case, we are getting a 1 1. So addition is 0, 1 carry. Okay. Now 1 0 addition is 1 plus 1 is carry. Addition is 0 and 1 carry. So in this case, we are getting a C out. Okay. Except all these, we are getting the C out as a 0.
Okay, sir.
Now, if we write a particular table of all 16 terms. So we find out that where the C out will be 1. Can you write an expression for that one? It is a form of mean term and mean max term. You can create a K map and solve this one for the C out. Only you consider the terms where the C out should be 1. Okay, so that is your mean terms. Now with the help of K map, with the help of Boolean simplification, you can write an equation for C out. Okay, and just solve it.
Okay, sir. Now I got it.
So can you solve the next one also in this comprehension?
Okay. So what is the next one is that when identify the logic state of the input line in the circuit to when P and Q are their maximum value. Okay, so what is the maximum value of P and Q?
1 1, I think.
1 1. So that is a 3. P and Q is 3. Okay. So what we are getting as the addition of these two? 6.
Yes, sir.
Okay. 6. So if we design a 6, so this is my 6. So can you relate which particularly LED is off? B is 0 and all are 1.
Okay, sir.
So if you see that A is 1, B is 0, C1, D1, E1, F1 and C1. All are 1, only B is 0. Okay.
Okay, sir. Okay, sir. And sir, last one also, sir, mux.
Last one. Now you want to replace it with the 4 cross 1 marks. So we have a 8 particularly combination is available 0 to 8 or 0 to 9. Okay, and we have to implement with the 4 cross 1. The output lines of 1 S and S naught. I S naught S1 and S naught is connected to mux selection line. Okay, so what is the possible solution is that we have a P and Q is 0 0 0 1 1 0 and 1. Sorry, P and Q either both are 0 0. One is 0 and second is 1. Third is the second is one is 0, second is 2, one is 0, second is third. Then you have to create a combination of in this way. Okay, so the 16 combination is possible. Now we have only the three things we are getting as a output as a S0, S0, S1 and S2. Sorry, S0, S1 and C out. We have only three output. Clear?
Not cleared, sir.
Mm. Like for example, we have created one is the P and second is the Q. I'm taking P and Q both are as a P and Q. Okay. So one P is 0, Q is 0. So what is the S1 and S0 is 0 0 and C is also 0 when 0 1. Okay. So the addition is 1. So S
Yes,
naught
sir.
is 1, S naught is 0, S1 is 0 and S carry is 0. It is a 0 2. So 0 2 representation is 0 1 0. So S naught is 0, S1 is 1 and carry out is 0. It is a 0 3. So the representation is this one. So both are 1 1. This is the 0. Now P is 1, Q is 0. Okay.
Yes, sir.
So we can create a 0 1 0. Then both are 1 1. So 2 it is a 1 0 0. If it is a 1 2, 3 3 both are 1 and carry is 0. Now if it is a 1 4. Okay, it is a 1 4. So in the case of 1 4, both are 0 0 and it is 1. Okay. So in this way you can create a all 16 combination. When P is 2 and when P is 3, again Q is 0 1 2 3, and when P is 3, again Q is 0 1 2 3. So there are the 16 combinations we can create. Clear? Now
Yes, sir.
we have to design with the help of 4 cross 1. So how we can implement a 4 variable term into the 4 cross 1 marks? We have already explained this thing in the lecture part. Okay, 4 inputs are available. So how can we design, or basically we can say the if three inputs are available, how can we implement that one with the help of 4 cross 1 marks? So 2 will be used as a select line and 1 will be used as a input line.
Yes, sir.
Okay. So now try it. If you have any other doubts, you can ask. Similarly, if we are talking about the D part, I also tell you that it is showing that we have to draw a Boolean expression when C is the output line. So you can see in a figure 4, I will go in the but will show part. Yeah. Okay. So where is the C line? C line is this particularly point. So when it is not glowing, it is not glowing in a case of 2, or yeah, only for the 2 it is not glowing. Okay, so if we have a input from 0 to 8 or 0 to 9, so only for the 2 it is C is not glowing. So when it is a 2, 2 representation is, the representation of 2 is what? S1. Okay, C is 0 when S1 is sorry, basically when it is a 2. So 2 is 0 1 0. So this is the S0, this is the S1, and this is the C out. So C out is 0, S1 is 1, and S2 is 0. S0 is 0. Okay. Now when C is 0, basically it is a max term, because when we define a term for the 0, it is a max term. When we define a term for the 1, output as a 1, it is a mean term. Okay, so when we define C is equal to 0 only for when 2 is displayed on the screen, so it is a basically max term. So how we create a max term? It is a combination of C out, S1 and S0. So can you write a max term for this one? It is a C out plus S1 bar plus S0. Okay.
Yes, sir.
If we write a expression for E, if I write an expression for E, or if you write an expression for G, so for the G it is not working for the 1 and 7. 1 and 7. Like for example, I am writing an expression for the G. So G is 0 for 1 and G is 0 for 7. Now 7 is not possible. 7 is not possible. Why? Because we apply the input P and Q. P and Q. And the maximum value of P is, if it is a 2-bit data, the maximum value is 3. If Q is also 2-bit data, the maximum value is 3. So when we add these two, the maximum possible addition is 6. So 7 is not considerable. 7 is not considerable. Okay? Only 1 is considered. Only 1 is considered. So when G is 0 for displaying the 1. Now what is the boolean number of the 1 is 0 0 1. So S0 is 1, S1 is 0, and C out is 0. So basically C out, sorry, C out, S1 and S0. So C out is 0, S0 is 0, and S1 is 1. What is the term? Because again it is defined for 0. So it is a max term. POS form. So it is a C out plus S1 plus S0 bar. So this is the expression for G. Similarly, if you want to write an expression for A, so for the A, it is A is 0, A is not working for 1, and A is not working for 4. A is not working for 4. And both are considerable. Both are considerable because maximum possible addition is 6. So 1 and 4 both are operatable. Now, when we are going to the 1, so it becomes a 1 0 0. So again, C out is 1, S1 is 0, and S0 is 0. Can you write a maximum for this one? So it is a C out bar plus S1 plus S0. So finally for the A, the term is C out plus S1 plus S0 bar multiply with C out bar plus S1 plus S0. So this is the expression for A. Okay, so you can write expression for any LED, either A, B, C, D, E, F, G. But the condition is that only the valid situation where the we have to display till 6, because greater than 6 is the invalid output. Greater than 6 is the invalid output. Got it? Why it is invalid?
Yes.
Why it is invalid? Because our input is 2-bit. So maximum possible value for the 2-bit is 3. So if we add a P and Q, so 3 plus 3 is 6. So the valid is 6. If we want to show the 7, 7 is not a valid. If we want to show 8, 8 is not a valid. Okay?
Yeah. Yes, sir. Thank you, sir.
Mhm. Okay. So thank you all.
Sir,
Yeah.
actually, sorry for asking again and again
Mhm.
regarding the live session notes. But
Mhm.
sir, when I saw it, means some notes are there, but some notes are they are vanished. Means they are not there.
Uh,
Like 20th Feb or the 3rd March, 5th March. Directly there is 7th March live session note.
mm, Actually, some session is only for the discussion, so maybe I am not save that particularly notes. That's why it is not available.
It becomes really helpful.
Uh, so better is that you can go with the video part. That is better,
Oh,
because maybe I have not saved that particularly live session notes, because sometimes I just realize that there is no need of this live session note because we are doing only the discussion part. So I have not saved that one, so that's why that particularly live session notes is not available.
uh, no, so it becomes really helpful to means revise it and know,
That is okay. That is
go
okay, but that is not available. That is not saved by me.
because the sessions are too much in begin length, so
Mhm.
it becomes really tough to find that.
Uh, if
And
even though if
sir,
yeah.
okay, means if possible you can try to create the notes of all live session if possible. uh,
Which are missing, okay, I will try to create that one.
yes, and
Okay.
actually one more issue, sir.
Yeah, yeah.
It was regarding the solution, means as when we solve the assignment questions, grid
Mm-hmm.
assignment and both practice assignment,
Mm-hmm.
when I'm stuck in a particular problem, and if I want to means watch the what you can say the grid assignment solutions or any solution,
Mm-hmm.
the solution looks like very incomplete because the steps are not in an sequential order, or the in between steps are added in that. Means the when I want to
Uh,
clear my queries, means to see that solution, it
so
becomes more chaotic.
can you tell me basically, because actually the solutions is only a rough idea that how we solve it. It is not
Yeah,
a completely particularly thing is that how every steps we mention in that one. It is a
not means
only a Mhm.
I don't want every step, but the initial step or the steps which are important, that how this came from this to
So you
that
can do one
was
thing, if you go with the particular solution part, you can do one thing is that you can tell me that, sir, particularly this question is we require some more steps for that one. So I can add some steps and then upload it again.
okay. Means it was in week 7, week 8 and week 7 content only. I was having
Week
problem
7
in
and
that.
week 8.
Yes, only in that only.
So with the
Uh,
if you know
and week
the
5,
particularly question
in
number
particular,
also.
I have not wrote the question numbers because I was
Okay.
solving randomly.
Okay.
So yeah,
Okay, I will check, and then if I think that we can add, I can add a more steps in that one. So I will add and upload it, re-upload
yes,
the
yes,
solution.
it will be
Okay.
means, very informative. Okay,
Yeah.
okay. Yes, sir. Thank you, sir. And sir,
Uh-huh.
hello.
Yes. Yes.
Is it possible that if you take lecture today, so today only you can upload the notes, or by the tomorrow morning or afternoon, if it's
Okay.
possible?
Okay, I will upload that.
Yeah.
In this, no issue. I will upload.
Yes, sir. Thank you, sir.
So I think we stop here. Thank you all.